All right, welcome everyone to today's Explainer. Today, we're going to unpack a topic that literally surrounds us every single moment of our lives. Yet, it's so often misunderstood when it comes to its sheer scope. We are talking about air pollution, and we're going to be traveling from the absolute microscopic level all the way up to massive planetary scale events. It's going to be a fascinating journey. So, to kick things off, let me throw a question out there to challenge what we might normally assume. Is all air pollution caused by human activity? Now, if you just watch the evening news, you'd probably instinctively say, well, yeah, of course. We picture factories, cars, and smog, right? But do me a favor and keep this question in the back of your mind as we go through today's material, because the real answer is actually a lot more complex and, honestly, way more fascinating than you might initially think. Here is our roadmap for today. First, defining air pollution. Second, broad categories of sources. Third, the scale of particulates. Fourth, natural sources. Fifth, real-world impacts. And finally, number 6, a summary and some final thoughts. Okay, let's dive right into section 1, defining air pollution. So fundamentally, what actually is air pollution? Well, it's defined as an undesirable change in the physical, chemical, or biological characteristics of the air. Notice how incredibly broad that actually is. It isn't just about human health. Our source material points out that this undesirable change is, or may be, harmful to human and other life, yes, but also to industrial processes, living conditions, our cultural assets, or it can even cause the wastage of our raw material resources. The absolute crucial takeaway here is that phrase, undesirable change. It is simply a disruption to the baseline equilibrium of our atmosphere, completely regardless of where it actually comes from. Moving right along to section 2, broad categories of sources. Now, the sources where these pollutants actually originate can be grouped into a few major buckets. We've got municipal or urban sources, automotive, agricultural, and industrial. Now, obviously, those first 4 are distinctly human-driven, or very familiar with those. But look closely at the last 2 on this list, forest fires and volcanic eruptions. This right here perfectly hints at the answer to our opening question. Nature itself plays a massive, undeniable role in atmospheric disruption. It's really not just us. Which brings us to section 3, the scale of particulates. Before we look at those massive global events, we have to zoom way, way in. As a fundamental rule for us in any scientific or technical analysis, we need to make sure our dimensions and units are perfectly understood. When we talk about microscopic particulates, we measure them in micrometers. That's represented by the mathematical symbol μm. Now, a micrometer is exactly 1/1,000,000th of a meter. To put that into perspective, we're dealing with extraordinarily tiny physical matter here, stuff that is practically invisible to the naked eye, yet completely capable of causing vast environmental changes. The numbers here brilliantly illustrate the massive mathematical variance in that microscopic world. At one extreme, you've got incredibly ultrafine fumes, measuring just 0.03 micrometers. At the other end, massive solid particulates like fly ash can range all the way up to a staggering 10,000 micrometers. Whether we're looking at solid dust and smoke or liquid mists and sprays, grasping this dimensional consistency is absolutely vital. Why? Because the exact size of a particle dictates exactly how it interacts with our atmosphere and with biological life. But here's the thing. Particulate matter isn't just industrial soot and ash. We really have to contrast solid and liquid particulates with natural biological ones. Our source explicitly lists naturally occurring organic matter as air pollutants too. Things like pollen, viruses, bacteria, fungi, spores, protozoa, and plant fibers. This perfectly reinforces that earlier definition we talked about. An undesirable change in the air can absolutely be entirely natural and biological in origin. All right, let's shift gears a bit. Section 4, natural sources of pollution. When we actually step back and look at natural sources of air pollution, we start to see that the Earth itself operates as a staggering engine of atmospheric change. Our source lists things like volcanic eruptions, forest fires, wind, storms, and, as we just mentioned, pollens from flowers. These aren't just weird anomalies. These are baseline planetary functions. They constantly inject millions of tons of those micrometer-sized particles right into our sky, and they do it without a single factory or car being involved. Let's see what that looks like in practice. Section 5, real-world global impacts. A volcanic eruption is basically the perfect example of the sheer, violent volume of material being ejected by nature. When a volcano erupts, it's essentially a gigantic natural cannon firing dust, smoke, and ash straight up into the atmosphere. And remember those micrometer dimensions we just learned about? Imagine billions of them. The thermal energy is so incredibly intense that it forces these pollutants high enough to fundamentally alter the physical and chemical makeup of the air on a massive global scale. And the real-world consequences of that, well, they are absolutely profound. When a newspaper headline screams, "Britain is shut to the world," we quickly realize that this isn't just some abstract scientific concept we're studying in a vacuum here. When natural pollution reaches these levels, it literally stops modern human society right in its tracks. Complete air chaos ensues. The sheer disruption of commercial and civic life that we see captured in those headlines is directly caused by the vast spread of these volcanic ash clouds. As they sweep across entire hemispheres, those microscopic solid particulates of ash and dust become a massive physical hazard. They hang suspended in the air, forcing the complete shutdown of airspace. It's kind of wild to think about. Nature completely grounded our most advanced technology.
And volcanoes are just one example. Global media frequently captures massive forest fires like the ones in the Amazon rainforest. These are literally planetary-scale smoke events. They inject immense quantities of microscopic smoke particulates, which, if you recall from our earlier data, sit snugly between 0.5 and 1.0 micrometers right into the air. The resulting atmospheric pollution from these massive fires can black out the sky over entire cities miles and miles away. It represents a massive, highly visible, undesirable change to the air's characteristics.
Okay, wrapping things up, Section 6, Summary and Final Thoughts. Let's take a second to summarize the highly structured, deductive journey we just took. First, we established an academically rigorous definition of pollution. We recognized it not just as toxic man-made chemicals, but as any undesirable change in the air's characteristics. Second, we strictly quantified microscopic particulates, learning to think dimensionally in micrometers, from those tiny 0.03 micrometer fumes all the way up to 1,000 micrometer dust particles. And third, we visualized macro-scale natural pollution events, proving that the Earth itself is a primary source of profound atmospheric disruption. Which brings us right back to our opening idea, and honestly, it leaves us with this final provocative thought. If nature is already capable of producing such overwhelming planetary-scale air pollution entirely on its own, how much more critical does managing our own human footprint become? We obviously cannot control the volcanoes or the winds, but we absolutely can measure, understand, and control our own output. I want you to think about that dynamic as you go about your day. Thank you so much for joining me for this explainer. I really hope this brought some incredible clarity to a highly complex topic. Keep learning, keep questioning, and I will see you next time.